Moving on to question 5. The continuous random variable x has the probability density function as described, where k and a are constants. Given that a of x equals 17 over 12, find the values of k and the values of a. Okay, so this is a very nice question. There's a few things that we should instantly want to do. We've been told that the expectation of x is 17 over 12, so we're going to calculate the expectation of x as we usually would. Also, since this is a probability density function, what facts do we know about probability density functions that will be useful? We know that if we integrate in between the maximum value and the smallest value, it should equal 1. So I'm going to start with that. So integrating in between infinity and negative infinity of f of x is going to equal 1. So I'm going to start with that. Integrating in between infinity and negative infinity of any function that is a valid continuous random variable should give me an answer of 1. So let's do that. Here, this continuous random variable has two separate functions, so I'm going to integrate them separately, sum them together, and the response or the answer should be 1. So looking at the top function, if I go ahead and integrate, k is a constant, so I'll take that straight outside. Integrate in between 2 and negative 1, x squared plus a. And then if I add on, okay, this time the whole 3k is a constant, that will come outside, and I'm integrating in between 3 and 2, just left with the 1 on the inside. Now this statement should equal 1. Let's process this integration. So I've got a third of x to the power of 3 plus ax in between 2 and negative 1 plus 3k x in between 3 and 2, and that should all equal 1. Let's substitute as appropriate. So here I'm going to get a third of 2 cubed plus 2a, and from that I'm going to subtract, being really careful with these negatives, a third of negative 1 cubed minus a. In this bracket is simply going to be 3 minus 2 equal to 1. Let's try and resolve this, just neaten it up. Okay, so working with the thirds, that's going to give me okay, so tidying that up, I get this expression, and we can go a little bit further to tidy up. So that's going to be, as we expand, 3k plus 3ak plus another 3k equals to 1. 6k plus 3ak equals 1. Okay, this will be useful later on. Let's just box that off and remember where it is. And we'll go back to the second fact that we wanted to use, which was that the expectation of x is going to equal 14 over 7. Okay, so a reminder, to find the expectation of x, we're going to integrate in between the maximum and the minimum, x multiplied by f of x dx. And in this case, we know what we want that expectation to equal. So let's go ahead and process that. Since there's two separate functions, once again, I'm going to do these two things separately. So first, I want to integrate. Let's take the k outside. X multiplied by x squared plus a in between 2 and -1. And then add on, integrate in between, once again the 3k is a constant, let's take that outside straight away. 3 and 2, x multiplied by the 1, and this is what we're looking to find. So, let's get that square bracket. This expansion I think we can deal with in our heads. X times x squared is x cubed. Integrating x cubed, 1 over 4, x to the power of 4. X multiplied by a is ax. Integrating ax, we should get a half ax squared. Limits, I'm adding on 3k. Integrating x is just a half of x squared, 3 and the 2. Okay, let's do some substitution. That'll give us 16 over 4. Minus a -1 substituted into there, so that's 1/4. Plus 3k, 9 over 2, minus 4 over 2. Okay, keep going, trying to simplify what we have here. Okay, to simplify, I can see that this is going to give 15 over 4. And with the a's, we should get 3 over 2a. Plus 3k, and inside of this bracket, we should simplify to get 5 over 2. Fantastic. Expanding those brackets, all that give us 15 over 4k plus 3 over 2 ak plus 15 over 2k. And reducing this all to 45 over 4k plus 3 over 2 ak, and setting that equal to what the question gave us in the very beginning, which was that the expectation was 17 over 12. So this is the second of the useful statements we can come up with. How will they work together? Okay, so with these two side by side, we have two simultaneous equations and many options on how to go ahead and solve these. I'm looking at this thinking that I want to use elimination. So I'm going to double the first one. That's 45 over 2k plus 3ak equals 17 over 6. Let's just label these. I'm going to bring in the second equation. I think you've guessed it, I'm going to subtract one from the other. That'll leave me with 33 over 2k. These middle terms are going to subtract and eliminate. And over here, I'm going to have 11 over 6. Okay, so resolving that, k should equal 11 over 6 divided by 33 over 2. Those numbers seem to align quite nicely. So k should equal 1 over 9. And if k equals 1 over 9, substituting back into the earlier equation, probably equation 2, 6 times 1 over 9 plus 3a 9, all equal to 1. Resolving this, that'll be 2/3 plus 1/3 of A equals 1. Some quick and swift rearranging. Third of A equals a third. This is looking nice. A equals 1. So in response to the question, K equals a ninth and A equals 1. And we'll finish up with a 1 marker. Here we were asked, write down the mode of X. Let's get a quick sketch. So I can see that the first part of the function would have been a quadratic, and that quadratic would have had a minimum point at X equals 0. I should say a minimum point along the y-axis, looking something like this, not worrying too much about the scale. At the end of this quadratic, X equals 2, and now that I know the actual values of K and A, I should be able to evaluate what that will be. So when X equals 2, the function is going to equal 1/9, 2 squared plus 1. 1/9 times 5, otherwise known as 5/9. Okay, so the height here is 5/9. The second function here is going to be a straight line. And what is that straight line going to be? Well, 3 times k. Let's just get, so 3k equals 3 multiplied by a ninth. 3/9, 1/3. Okay, so I need a horizontal line. There is no gradient to that function. A horizontal line at 1/3. Let's just say a third is here. This is what the rest of the function will look like. Okay, so the question being, what is the mode? And we can see right here, the mode occurs when X equals 2. Mode equals 2. All right, nice. On to the next one.